Well, hello, physics students. It's Mr. Thrasher. Oh, we are doing online learning still. This is week number 8. In this week, we are going to learn how scientists know the atoms that are in stars, what stars are made of, like our sun. We're going to do another activity similar to looking at fingerprints, but this week, not the fingerprints of people. The fingerprints of stars. Interesting. Let's get started with our first video this week. Okay, we have a physics objective. I know that atoms can absorb and scatter light. This is what we're going to talk about in this video. Atoms absorbing and scattering light. We'll remember what these words mean. Don't worry. Okay? Now, for your what do you think? It says, what is something you remember about atoms? We talked about atoms a while ago. We learned things about atoms. What do you remember? Maybe what is an atom? What is the size of an atom? I want you to write one full sentence. Something I remember about atoms is, it's okay if you're just trying to make a guess. You don't have to go on Google. I don't need a Google answer. What do you remember? We talked about atoms before. Go ahead, type what you think. Okay, we're going to remember atoms as we go in this video. But first, let's remember a little bit about how we see light, how we detect light. It's all about when it enters our eyes. That's important. If our eyes are closed, we don't see light. Or if there's light hitting the back of my head, it's not going in my eyes, so I don't see it. If I see something, it's because light enters our eyes. That's important. And I want to show you an example of this with something in English called a laser pointer. I don't know what it is in Spanish or Chinese, I don't know. But a laser pointer, have you ever seen a picture, or maybe you have one at home and it looks kind of like a pen, and you shine it and it has a red dot. The laser pointer shines light. It shines usually red light, though they have other colors. Now, when the laser pointer shines light on the wall, the light hits the wall and it bounces off. It reflects. Remember that word, reflects? So here's the laser pointer. Here's the light. It travels this way. Let's pretend this is our wall. And then it bounces. It reflects. And look right here. Some of that light goes this way. Some of the light goes this way. Some of the light goes this way. And if your eye is right there, this person has light entering their eye, so they see red. But have you ever noticed, have you ever thought, if the laser pointer is shining, you don't see red. You don't see red here. Unless you go like this. That's dangerous. But if you have the laser pointer, there's no light that you see. Look, you don't see any red light here because the light is traveling this way. Is it entering this person's eye? No. The light is not going like this. No. It's going in a straight line. It's a little difficult. This light is not entering their eye, so they don't see it. They don't see this light. They only see it after it reflects, because then it reflects in many different directions. It's like scattering. And then some of it reaches your eye. That's why you can't see this type of laser pointer. Oh, okay, so that's how we see light. Remember, we had 3 different words for light. And it's kind of like what happens when light hits an object. We said that light can be absorbed. There can be absorption. Here's an example. The water is being absorbed by the sponge. Means the light stays in the object. The object holds on to the light. We also learned reflection. In reflection, the light bounces off. Think of a mirror. If you're standing in front of a mirror, muy guapo, the light is reflecting. It's bouncing off. Reflection. And then lastly, we learned about scatter. And we're going to use this word a lot this week. Scatter is when light bounces, but in many random directions. Here are some examples of scattering. Here comes the light, and then bam, scatter. Bam, scatter. It does it in many different directions. Okay, that's important to remember, especially absorption and scatter for this week. Let's remember about atoms. What did you say in your what do you think? What did you remember? Atoms are very small. Remember that everything around us, including the computer, including your skin, including your eyes, all things are made of atoms. And there are many different types of atoms. Also, maybe you remember that in atoms, there are protons, neutrons, and electrons. There were 3 pieces. Okay, so atoms are very small particles. Okay, they make up everything. Here is some new information for today. Atoms absorb, reflect, and scatter light. Okay, remember we learned why the sky is blue. That's because air particles, atoms in the air, scatter certain types of light, blue and purple light. Okay. So we know that different objects are made of different atoms, chemicals, similar. And now atoms can absorb, reflect, and scatter light. So with that, Mr. Thrasher wants to show you a simulation. Normally we do this in class. Oh well. Here I have a light. And here I can choose the type of light. Remember how we learned the different types of light? Okay, I have visible light selected. And when I turn this on, it's going to shine some light. Okay. What I have here are different types of atoms. Some of them are called molecules, if you've heard of that word. That's just having like 2 atoms together. I'm going to keep saying the word atom. So carbon dioxide, that's 3 atoms. Look, 1, 2, 3. And look what's happening right here. I have visible light. It's kind of like yellow. The visible light is moving past these atoms. Is this atom absorbing that light? No. It's kind of like ignoring it. It's like, it's not absorbing this type of light. Let's try a different atom. Let's try this one. This has 2 atoms, carbon monoxide. Visible light. Oh, no. Oh, man, boring, Mr. Thrasher. Let's try nitrogen. Nitrogen has 2 atoms. No. Let's try water. Water has 3 atoms. Let's see. Is water going to do anything? No. Let's try nitrogen. 3 atoms. Ooh, did you see what happened right there? The nitrogen absorbed. And then what did it do? Oh, look at that. Oh, the nitrogen absorbs and then it scatters, absorbs. Let's wait for it. Oh, come on. Absorbs, scatters. Oh, not the other atoms though. So not all the atoms absorb. Let's try going to a different type of light. Here's infrared. Here's infrared. Let's see if water will interact with infrared. No. Let's see. Oh, now water, it didn't do it with visible, but water absorbs infrared. Interesting. Let's try microwaves. Let's see. Oh, look at that. Water is absorbing microwaves and then scatter. Absorb, scatter. Absorb, scatter. Let's see. Well, let's watch water. Ooh, absorb, scatter. Oh, let's see. Does carbon monoxide absorb microwaves? Oh, no, I don't see anything happening. Interesting. So, different atoms were absorbing different types of light, and they were different. Water absorbed microwaves, but carbon monoxide did not. Interesting. Okay, so let's think of this a couple ways. If the light was going right by and your eyes were right here, that light would enter your eyes and you would see it, right? You see light when it enters your eyes. The light enters your eyes. But when we had one type of atom, if it absorbed light, absorb, scatter, absorb, scatter. If it absorbed this light, is there any light to enter your eyes? No, so you don't see it. Would this person see light? Yeah, because it absorbed and then scattered. Oh, so if the light is being absorbed and scattered, sometimes you might see the light and sometimes you might not see the light. We're going to focus on this right here, seeing light that is scattered. So we have many different types of atoms. Helium is a type of atom, neon. If you've ever seen like fancy lights, like orange, red lights, those are sometimes called neon light. It's a type of atom. Mercury is a type of atom. Look at that, that's a big atom. So what we saw from our simulation, that website, atoms absorb and scatter only some light. It wasn't all of it, it was only some. And different atoms absorbed and scattered. Absorbed, scattered. Absorbed, scattered. Different types of light. Interesting. Now, I'm sorry we're not in class because this is something we would do in class. Mr. Thrasher has tubes. I have containers of different atoms. For example, imagine I have this container of helium. Helium's a type of atom. And I put the tube, I put it like this, into this machine. This machine gives this tube, gives the atoms energy. And when the atoms get energy, they scatter. And this is the light that helium scatters. Not all the types. Look, it scatters red. It scatters kind of green. A couple blues. And look at this, maybe a purple. Maybe a purple. This is the light that helium scatters. Oh, interesting. And this light is unique. Solamente, only helium will scatter these colors. It looks pretty. Only helium scatters these types of light. It is like helium's fingerprint. If a scientist sees these types of light, they say, that looks like light from helium. Oh, this is like fingerprints. There are many different atoms, but all atoms have their own type of light. This is an atom called potassium. This is the light potassium scatters. This is this is an atom known as lead. This is the type of light lead scatters. This is called calcium. This is the light that calcium scatters. Just like you have fingerprints, light has fingerprints. And just like your fingerprints are different than everybody else's, light or atoms, the light they create. Look at this. Different, 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 different. The light atoms create, like fingerprints, are different. Sometimes scientists, real quick, they make it in color. That's really nice and pretty. But sometimes, like if you don't have a color printer, sometimes they just use these black lines. And this is representing, remember, color, it's based on the wavelength. So this right here, this star is scattering kind of a red light, and it's scattering kind of a yellowish orange light. Oh, okay. So here's what you're going to do. Remember how you practiced being a detective and you looked at the fingerprint to identify teachers? You're going to look at the light and identify the atom. Okay, this is a little more difficult. There's only 3 questions, all right? This is what you're going to do after this video. Mr. Thrasher is going to help you with number 1. It's a little difficult, so pay attention as I describe how to do this activity. This is the same as question 1 on the activity. So here we have a mystery object. This is what we need to investigate. And we see this light. So there are atoms in this mystery object. And looking at the light, just like looking at fingerprints, we can decide what atoms are in here. Just like if you found my fingerprint on the computer, it means Mr. Thrasher was there. So let me demonstrate how to do this, okay? I'm going to look here, mystery number 1. It says 2 atoms. So I'm looking for not 1, I'm looking for 2. It will be a combination. So I look at my mystery object. Okay, pretty. Oh, look at this. Okay, look at this. I have a big red. You see this? Mystery object creates red light. Well, let's look. Here are my fingerprints. I have 4 atoms, 4 possible atoms. We want 2 of them. Let's see. Well, if I look right here, see this red? Look right here. Oh, it looks like the same. It's right about 650, right about 650. Red, red. Oh, this is similar for the hydrogen atom. Let's look at hydrogen a little more. Let's investigate. So hydrogen has red. Let's see. Oh, look at this. Look at this blue. Look at this blue right next to 500. Do you see blue next to 500? Oh, yeah, look. La misma. I see the same thing. Okay, let's keep looking. Oh, this one right here. Ooh, dark blue. Do you see dark blue? Oh, and look at this one. Ooh, like a purple. Oh, I see the fingerprint of hydrogen in this mystery object. All the same colors here are in here. So 1 atom is hydrogen. Here's where it's difficult. What is atom number 2? So we got hydrogen, but is the other atom helium, sodium, and mercury? Difficult. But let's see. Maybe I'd be like, look at this. You see how we have 1, 2, 3? Well, that's not in hydrogen. So these 3 must come from a different atom. I bet you can figure out the other atom that has these 3. So for question 1, hydrogen is one answer, but we're looking for another. Is the other one helium, sodium, or mercury? And then you have 2 more. So there's only 3 total. It's a little difficult. Take your time. Take your time. There's just 3 questions. Just 3 questions. Okay, that's the end of this video. Thank you for watching.